Okay, so I'm Sainath. So before starting, just a quick survey. How many of you have heard about or used containers here? Okay, yeah, more than half, I guess. So this talk is like exploring Zen for basically container use cases. How can we use Zen and basically take all the advantages of containers, especially Docker. So let's start. So containers are being adopted widely for mainly application development and deploying. They use OS-based virtualization like namespaces, one of the technologies mainly containers uses. So they are a lightweight alternative as they are shown. I mean, for compared to traditional VMs. But traditionally VMs have their own strong points. For example, one is application basically offer better isolation between guests. So let's see how we can actually complement Docker containers or any containers for that matter if we use VMs in conjunction with containers. So we'll just go through the containers for a brief introduction in order to just get warmed up and then see how we can use VMs. So containers today they use mainly three Linux technologies. They are C groups, namespaces, and union file systems. So C groups is for mainly resource controlling the applications, and namespaces is for isolation between the applications, and union file systems are like a low cost solution for individual mount points for all for applications. So for example, if we have two applications, we just name them like container A and container B. They basically run on the same kernel, meaning the same host OS, and they are isolated by using namespaces. So namespaces are just like couple of syscalls to basically isolate different namespaces like PID or network or UTS, for example, and they have their own. They have their own. They think that they are the only ones running on their system. So in that manner, we can run multiple applications in containers that are isolated using namespaces. Docker has taken this technology and they have become like a one-stop solution for basically running, building, as well as packaging them up as containers. So they have so building and packaging are really the selling point for containers because they can package the application and its dependencies like middleware or any libraries, and then they can basically make that package run anywhere on any other system other than basically if some developer uses his own system to develop an application, package it up, and then they can deploy it in any other system like production system or test system or any other system. So currently the isolation in containers is using namespaces, but are they strong enough, and how is the like the ecosystem? What is the comments that we notice? So this, since the containers run on the same host OS, any vulnerability or any potential hole in the kernel can be exploited by malicious applications or images, and then they can basically peek into the other application data or what it's doing. So also, if we enable these new technologies, C groups and namespaces, basically we are introducing more syscalls and basically more attack surface. And just an online survey saying like more than 30% of Docker images currently current images and are actually having security vulnerabilities. And another thing just noted here is It's from CTO from Google. He says for the data center use cases, for now they actually trust only VMs as a solution for isolation. So we need, looks like we need better solution for isolation, and that definitely would be using VMs. But how we could, like what can we do to run applications or containers in VMs? So if these are like these the containers, and VM containers are basically we need not have namespaces. So because we use guests as isolation between two containers. So each I just showed like each container is running its own VM here, and also we can group multiple applications or containers within a VM. For example, if you take a multi-tenant cloud provider, he could choose, or the client could choose to run a single client, or a single tenant can choose to run his containers in a single VM because he trusts his own code or applications. So that would actually use less resources because all these you can bunch all these applications within a single VM. So how could we use Zen here in this complete story? So meaning how could we use Zen as an infrastructure or framework? So, these are the, like what I mentioned earlier, like we can group containers from a single tenant onto a VM, and the infrastructure, for example, Zen is already time tested, so we have great infrastructure. And now we will see why PVH. So PVH is a good choice for application containers because so for containers it's about boot time. So fast to boot or bring the application soon. So PVH is directly boots the guest kernel in directly to the kernel, skipping the BIOS, and we get PV performance for disk and network. And for CPU and memory, we basically use HVM extensions here. Also, apart from these, PVH is a good choice because we don't need any special like PCI devices to basically expose a emulate PCI device and use any device model there, so we can get rid of those. For example, data center web applications or anything, they just need a disk and network, and basically they don't need any special VFs or any kind of PCI devices. Compared to HVM, it's better because there is no QEMU device modeling there, and getting rid of QEMU, we basically get rid of the memory footprint of the QEMU takes on the host, and also we remove the attack surface, basically QEMU code surface, and there is no BIOS, and it's faster to boot. So now we need to, like, let's look at how we can use so Docker. Another selling point is how they package their images and how they can deploy them anywhere. So let's see how we can use the same Docker image within the Zen guest or PVH guest. So we can run a Docker daemon in DOM0. And so Docker, for example, uses multiple storage backends. One example is device mapper backend. So once we run Docker, run, for example, Ubuntu, it basically creates a container block device on the host. So that is the Docker storage device that I mentioned there. And then we can actually launch PVH DOM-U with exposing the same container block device as the root device for the PVH guest. So in this way, we can actually use the same Docker image and the advantages that comes with the Docker image in terms of their portability with, for example, using Zen containers here. So Another strong point of Docker is their boot time. So how can we reduce the boot time here if we use a VM here? So VMs are typically known for longer boot times, right? So what we can do is we can actually use a very slim or minimal kernel that is having a really configurations that are actually needed to boot and then run. And then we use a special, we can use the init, special init RD, or for that matter, we can use systemd also, or any kind of init to basically, the main role of the init would be to mount the container root file system and to configure the network. And then as I said, we use the same Docker container volume that has been created by the Docker daemon on the host. We expose that as a root device to the guest. And networking, we can use the same Docker subnet. Sorry, Docker subnet IP, and basically, if we use Docker subnet IP, we can bridge any other container running on the same host so that they can interoperate with each other. These Zen container and any other bare metal container running on the same host there. So the three important things we need to configure the guest with are storage. We have to pass the Docker device mapper container volume, and we need to pass the information what is the entry point for the Docker container, what it wants to run. For example, Docker Ubuntu, and if he says run bash, we have to pass that information to the guest so that when it launches the application, it will launch with that as the entry point. And if you want to pass the network IP, we have to pass the network IP. For example, Docker has its own subnet where it has its own IPs, so we can pass that information as well to the guest. Yeah, that's it. And we made a small comparison between PVH and HVM. So if you see, PVH is if PVH takes around all these numbers are milliseconds. I missed that there. So PVH takes 1.3 seconds to boot, whereas HVM, because there's a bias to boot also, so it takes around 2.5 seconds here. And yeah, so if just a comparison, so containers versus VM or Zen containers. Containers fast to boot, so even VM containers can also boot in a second. In my case, it took a little over a second, but if we look closely at the kernel and its configuration, we can make it also maybe boot within a second. And sorry, I didn't show that. So the guest, yes, go ahead.
What's the unit of this?
Milliseconds. Milliseconds? Yeah.
So what's the 224 seconds? Milliseconds means the time spent by.
So this is for basically the Excel tool stack to set up the domain. Before it starts the domain, it is the time it took to create the domain. And
only 200 milliseconds.
Mm-hmm. Setup by meaning setup by it means that how to create the Zen store entries and everything, device model ready for the domain. Before it unpasses the domain, how much time it took to create the domain.
Okay.
Yeah. So the guest takes in the example in our case it took only 16 MB of the guest used only 16 MB. So yeah, basically VM containers can also take only tens of megabytes, and since we are using the same Docker image to run within the VM, we are actually taking the advantage of the Docker as well into the VM containers. So in the case of PVH, the next steps I just listed a couple of them. One, so Docker supports mounting host volumes into the container. So if you want to support the same feature, we need to have a PV solution for virtual file system. And as I have shown earlier, we can bunch group of applications inside a VM. Then question comes how to resource control them. So we can use systemd inside the VM as its init application, and then we can basically resource control those applications inside the VM. Yeah, that's it. Any questions? Yeah, sure.
Use the mic. So you talked about getting things like the init path and IP address into the VM. How do you do that?
So in my experiment, I actually did by using, I created new Zenstore entries to just play with. Yeah.
Thanks.
I just created two new entries for application path and the IP, and then I read it back in the guest. Yeah. Or normally we can use any serial communication between host and the guest and actually pass this information.
So is the code already available somewhere to look at?
Which part of the is it for the guest or?
No, generally of what you've done. You know.
Oh, so we actually did this manually. We didn't automate these things.
Ah, okay.
Yeah.
Do you have any plan to, like you said today, maybe you didn't really package your solutions somehow, but do you have any plans to release it somewhere that is more widely available or directly usable for users?
We have planned, we actually plan to do everything, integrate this flow into the Docker, but yeah, we would do that. Yeah. Yeah, question.
Can I ask you how your solution is different to Hyper?
So it's not a different solution. It's just the same concept. So we just use different kernel and initRD for the difference. Yeah, but the concept is the same.
Okay.
So one of the strong points of containers usually is higher density, at least is what is maintained. So have you done any measurement on that, or do you have any view on whether memory deduplication would help? Or
No, we haven't done that. We just measured the guest memory, yeah, that's it. Okay. So that's it then. No more questions.